Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
To this point, we've demonstrated how to call into a Visual C++ DLL, capture the return value of a function, and display that value here. That's what this 42 is. That may be a realistic use case in some scenarios, but you probably have more interesting return values or data that you'd like to share between your DLL and your application, or even pass values into the application. So let's create something a little more interesting. Let's try a string. That's probably the next most obvious type. We'll create another function that'll return a constant character pointer, and we'll call it get star. In this case, we're just going to return a string constant. I'm not going to do any fancy allocations or anything for this test, so should be able to build the DLL. And then, as I demonstrated before, we need to create an import library. We need to update our import library, really. So we're going to overwrite. It's going to overwrite the import library that we have. And it's first we have to give the destination file name, .lib. And then there we go. So now when we go over C++ Builder, now we're going to have, let's say, another control, or we could even use the same label. Instead of calling that function, we'll call the getStir function. And then do a make. Okay, and we'll try running it. So it linked good. That means it found our new getStir symbol from the DLL in our import library. That's good. We run it, and it says hello world. So it passed back our string constant, and we were able to print it just fine. Okay. So now let's try some dynamically allocated memory. To do that, we'll use strdup. That's the equivalent of calling malloc with the string length of the string you pass it, and then copying it into that string with a null terminator and returning that. So it's kind of doing all those things in one operation, and it's going to return the value. And if you're familiar with strdup, you know it's like malloc. You know that you should be freeing the memory. I'm not going to do that here. I'm kind of purposely creating a memory leak here. And we get a warning about it being a deprecated function. That's fine. There's ways to disable that in your Visual C++ build environment, but for now we'll just ignore the warning. Anyhow, you see it works fine. But we know now that there's a memory leak, so if you ran any tools that capture heap leaks or corruption, something like Valgrind would report a memory leak on that strdup allocated memory. So just for fun, let's see if we can free that memory. So we'll say, we'll go ahead and print it, and then we'll try freeing it. Now, I can tell you this is not going to work, but you might try this, and then I want you to know why it'll fail. The DLL has been compiled and linked with the Microsoft C runtime, so it has its own allocation heap for use for functions like malloc and calloc and strdup. So when we get that pointer, that's fine. It's pointing to that DLL's heap memory, which we can access just fine for read. But our free call is going to call into the Embarcadero C runtime library, which has a different heap, and it's not going to know what that pointer is. It's not going to be able to free it. So it'll probably throw an exception. Before we can call free, we need standard lib. What is going on? Why is free not defined? No mention. That's interesting. So you have to call colon free if you want to call a standard C library function. Okay. And then we need a typecast, because this is C++. All right. So it did not throw an exception, but I do know from experience that that memory is not actually freed. So what you would need to do in this case is you would need to create a function in the DLL that will free that resource and call its free implementation. So let's create a kind of equivalent here, or a counterpart to this function. Call it freestir. You pass it the string to be freed. It calls free. And we can't forget the DLL call decoration there for the calling convention, consistency. So we also need standard lib here. And we have the same warning about C++ness. And we need to do that same creation of the import library back to C++ builder. Again, I'm not freeing it, so we know there's a memory leak there. So instead, we're going to call that freestir function. Basically like a little wrapper around free. So a problem I'd like to demonstrate now is a situation where the program compiles and links and seemingly runs okay, except, well, I'll demonstrate the issue here. So we run it. So we see this privileged instruction exception. That's actually happening when it's executing this freestir function, which is calling into the DLL. Looking at the DLL, there's really nothing too complicated, it just calls free with a little typecast here. So this is telling us that this problem with the calling convention. We are using DLL call here. We don't technically need to do this VC test API macro in the actual implementation, just in the header file. The problem is we have a mismatch here because we're only doing this standard call type when it's a Borland compile, which is the Embarcadero tools. So simply always defining this, otherwise it's going to default to cdecal when compiled with Microsoft Visual C++. Should fix the issue. So we'll rebuild that. We're missing need to use the macro everywhere now. And then build. And then make sure our import library is up to date. And then remake this. Application. And we run it. Now there's no exception. So it successfully allocated the memory in the DLL, returned it, we set it to the caption of this label, and then we freed that memory. And the label is fine. It has its own copy of that memory. It doesn't need to have this pointer be persistent. So it's fine to free it. We just can't free it using the Embarcadero C runtime library. We have to use whatever was in the DLL. So in this case, it's Visual C++. We need to make sure that whatever's allocated by the DLL is freed by the DLL. And the converse is the same as well. So if you allocate memory in the application that's built with C++ Builder, you can't let that memory be freed by the DLL. So let's go ahead and try an instance of that as an example. So we already have a freestir function we can call. So I will just allocate another string and call freestir. So in this case, I'm allocating it in the application and trying to free it in the DLL. And we get a debug assertion with a invalid heap pointer. We're passing a bad pointer to the free function in the DLL. So this exception actually comes from the DLL. If we want to debug this, we can hit retry. It should pop up Visual C++. It kind of popped up a window and then went away. See if we can attach to it using Visual Studio. So I'll say debug, attach to process, project 1. look at that. By attaching in Visual Studio, I'm able to see where the exception is actually occurring. Now, there's an exception to this rule. Well, not an exception, but a workaround. So if you really want to do that operation where you allocate memory in either the application or the DLL and you want to free it in the other entity, you can use these Win32 API calls, heap alloc and heap free, and attach them to the process heap. This is kind of a global heap for the process. It's not attached to the C runtime library. So you can't use stirdup in that case. Yeah, stirdup won't work for the because you need to actually call malloc. These macros are only for malloc and free. Let's see if we can give an example. So we're going to call free on this. Let's go ahead and build this. Can't build while the DLL is running. Try deleting it. Access is denied. Oh, looks like we got a couple ghost processes. There we go. I should be able to delete that. Yeah. Okay. Let's copy those macros into here. Now we're going to do something like malloc 5. So now this example is just going to allocate 5 bytes, copy the string test into it, and then see if we can free that same memory successfully now that we're using that heap free implementation. Okay, no error. Anyway, so that demonstrates how to allocate memory using the Win32 API functions heap alloc and heap free. You can allocate memory in the application, free it in the DLL, or the opposite if that's your desire. But that does require that you do not call malloc and free, but instead use these Win32 functions from Microsoft. Since we are talking about a C++ project, and the normal ways to allocate and free memory in C++ is the new and delete operators, I wanted to clarify you can't use those either. That's the equivalent of a malloc and a free, and you can't perform, say, a new operation in the application and then a delete operation on that same object in the DLL. That's not going to work. The only allocation and free would be through the Win32 calls, heap alloc and heap free. It might be better to not use macros, but instead create functions. You might want to create the equivalent of, say, calloc, where it zeros the memory, or maybe your free checks the pointer to see if it's null and performs an assertion, something like that. But these macros do work if you just want to do a global kind of macro replacement on all calls to malloc and free with heap alloc and heap free. So the Microsoft help for those functions. So there's also heap realloc, a realloc equivalent if you wanted to make this more complete. You could have a macro or function for realloc. If you wanted to reallocate memory rather than freeing it and allocating a new block, but rather resizing existing block, you could use a macro, kind of like this pointer. Let's put a breakpoint here. What if I can attach to it with a second debugger? Attach. No, can't do it. Okay, so you can't attach if there's already a debugger attached. Fine. So a better way to test this, because I want to be able to step into that code, make sure it's executing as I expect. So instead of executing this code when the form is shown, instead I'm going to create a button and then just perform these operations when the button is clicked. Go to my palette of components. T button is fine. What we want to do is an on-click event. If you just double-click, you'll get the onClick event. You move the code there. Okay, so what this allows me to do is attach with the Visual Studio debugger and then click this button, which will execute this code, and I'll be able to see it call this freestir function in the DLL. So I'm not using the RAD Studio debugger in this case. I've got my button. I'm not going to click it yet. I'm going to go over to Visual Studio, debug, attach to process. In this case, the program name is called Project 1. I'm going to attach to it. I'll go ahead and put a breakpoint here in this function. Thank you. Now I can click my button. It should hit that breakpoint. There. So I know it called into my freestir. I know it's about to call free, which is actually this macro to heap free. And that was successful. I don't have the symbol. I can't load the symbols of the rest of the project, so it's best just to continue running. And then if I want to do any debugging, I would now want to detach. Okay, so in this case, I'm going to demonstrate how you can debug the same application using both debuggers. So I placed a breakpoint in the button click event for this button. So if I click the button, hit the breakpoint, go into the function, I can step through the code. If I want to debug, say, this freestir function, which is in the Visual C DLL, I would need to detach from the program in CBuilder. The program is still running. Now I can go into Visual Studio, debug, attach to process. Again, it's called Project 1. Attach. I have my breakpoint on the free function there. I go here, I click the button, and voila. Now, if I step out of this function, it's going to jump back to the C++ builder code, which I don't have compatible symbols in this debugger, so it's not really going to work. But I can debug this function that I'm in, no problem. See, symbol file not loaded. So it can't continue to debug, but I can definitely switch back and forth by detaching and reattaching.